So, hello everybody. Our project title is IoT based automatic accident detection system. You know that millions of people die in road accidents and victims' life can be saved if rescued timely. The main objective of our project is that our system reports accidents and also tell us what type of accident it is, like if it is a collision or a rollover. So, this is a setup which we use to collect data set. We collected all our sensor to the Arduino Uno and it is connected to the laptop with Excel data streamer. With Excel data streamer, we collected the live data from the sensor directly using the Arduino Uno serial monitor. And this is the screenshot of our data set output where here AXYZ represents accelerometer axis. GXY is that represents gyroscope axis. ALA is the absolute linear acceleration, which is to normalize and obtain the magnitude of velocity. And finally, in the output column, 0 says no accident, 1 means collision, 2 says rollover. Raspberry Pi connections. The MPU 6050 sensor, the vibration sensor, and all other sensors are attached to the Arduino Uno. And now from Arduino Uno, we connect it to the Pi using cable as shown in the figure. And then it sends the data serially to the Pi. We also have data coming in from the GPS sensor in the Pi itself. And at last, all these sensors will be, all the values of these sensors will be sent to the cloud. Nishant will continue.
So, Namespace is one of the models we have used, and this is the code part. We take the data set and apply namespace model and train it. Here we take live input data from the sensors using the serial monitor of the Arduino Uno. And the code for that is also here on the right side. The output here is the proof that this model detects with 93% accuracy. Next slide. This is a video for collision. As you can see, once I run, the car is in idle state, the output shows no accident. But when it actually collides, you can see the output detecting and it says no collision. Collision. So it's no accident currently. And now when the accident, it says collision. It just went by. Say it one more time. Yeah, it's collision. Next slide.
Yeah.
Similarly, for the rollover part, we see the output mentioning rollover when the rollover accident occurs. We also observe that this is accurate. See, when it rolls over, we get the rollover in the output section. Next slide. However, the problem with the namespace is that it is a binary algorithm. It cannot predict several classes. It can only say an accident has occurred or not. So we need to predict several classes such as the collision, rollover, and no accident. So for that matter, we go for the KNN algorithm. This algorithm can predict all the classes at the same time. This is the code, and we shall now see the demo video for the same. So this is the KNN algorithm. It can detect both collision, as you saw just now, it went by. It goes really fast, so I have to scroll down faster. Yeah, and now for the rollover part. See, when it rolls over, you can roll over in the output section as well. So both of these outputs are achieved through a single algorithm, KNN algorithm. Proceed to the next one.
Okay. So to be able to use our GPS module effectively, we needed to get a fix for our GPS. So in order to do that, we used a software called uCenter, where we could monitor which satellites we connect to and if our values are accurate. So as you can see from the image, we successfully connected to 7 satellites and then used it on our Raspberry Pi. Next, please. So this is the values that we got in the Pi for the GPS. So out of these values, we only required the GPGGA value, so we had to extract that out separately. Next. Okay, so this is the entire output that we got from both the sensors and everything from the Arduino and the GPS. So the sensor values were all fed into the KNN model, as Nishant had explained, and the GPGGA values were extracted from the Pi. Next, uh, please, uh, please pause the video. Please pause the video. Okay, thank you. So we used the IBM Watson Cloud platform as it was very simple to use and it had a lot of tools that we could exploit. So first we created our free IBM Cloud account, and from the Watson catalog under services option, we could choose the cloud and database. This database was very helpful as it stores information in the JSON format, which makes it easily scalable for our needs. After giving it a suitable instance name and choosing the IAM authentication method, we create the cloud and database and deploy it. So next, what we see in the PPT is we set up the IoT platform by launching it from the resource list. And in the platform, we created our device as shown. So in our case, we named it the Arduino Uno and gave our device ID to be 123. After creating our device, please play the video. When we ran the client server code on the Pi, the sensor values were received in the platform as it can be seen in the recent events tab. So after we know we have the values being conveyed from the device, to be able to use this information to our advantage, we also created a standard application. Please pause the video. After creating the standard application, we took down the API key and added it to our Node-RED flow as can be seen. So next we move on to the creation of a very basic website. After going to the Node-RED flow editor, we can create our flow and deploy it to get our website. Uh, please play. So the values received in JSON format are extracted to each individual property and compared to their thresholds. Then the respective messages goes out to the hospital and the loved ones. The details can be seen in the page and the position on the map is also shown, thanks to the various UI features and the world map feature. It zeroes in on our location. Okay. So next, what we also did was we used the fast2SMS service provider to send our emergency messages based on the output of whether the accident happened or not. So if the value was 1 or 2, we send the messages to the loved ones. We activated it using a simple authorization key and the token to get the messages on our phone as shown in the figure below. Yes, that is the end of the presentation. Thank you.